Hello everyone. Today we're going to go over notes on the tangent function. So let's review a little bit. The tangent of an angle. So suppose the terminal side of an angle theta in standard position intersects the unit circle. This is when knowing the unit circle is very beneficial, and I will put that up again here in a few minutes for you. It's going to intersect the unit circle at point xy. Then the ratio y over x is the tangent of theta, and that's denoted by tangent of theta. So in this diagram, of course, we said xy on the unit circle was cosine sine. So let me grab that again and show you the unit circle. All right, I think we can all see that. Okay, and I have all the little notes on here that tell us that xy is cosine sine, and you can freeze this and look over it so you can memorize all the different degrees and what their equivalent radians are. Okay, this is very helpful, very important. So you can look at this, refer to this, draw this out, whatever makes it easier for you. I think if you can draw it out, it'll help it stick in your mind, and then you'll have a hard copy to use for the homework problems. All right, now we have the unit circle. Again, it's called the unit circle because it goes one unit in all directions. So in this diagram, we know that x is the cosine and y is the sine, so it's cosine sine. And since y over x equals tangent theta, then tangent theta is just sine theta over cosine theta. So if you know your ordered pair, you'll be able to calculate your tangent. So let's look at an example. It says, what is the value of each expression? And we're going to do these without a calculator. So the tangent of theta. Okay, you'd go to your unit circle and you'd go, tangent of pi. You'd go to your unit circle and you'd realize, okay, pi is all the way over here. What is the ordered pair where this line intersects the unit circle? It's -1, 0. So that's always in the alphabetical order, cosine, sine. So we know the tangent, sine theta over cosine theta, sine over cosine, 0 over -1 is 0. Pretty simple. Let's look at the tangent of -5 pi over 6. So we would have a negative radians. So we're going to start and we would move this way and we would go to -5 pi over 6. And the ordered pair there would be negative square root of 3 over 2 and -1/2. So now we have to remember how to simplify complex fractions. We're going to say the tangent equals -1/2, which is sine, over negative square root of 3 over 2, which is cosine. Our 2's cancel, leaving us with 1 over the square root of 3. Okay, we have to get rid of a square root in the denominator. So we're going to multiply the top and the bottom by the square root of 3 over the square root of 3, which equals the square root of 3 over 3. So the sine of -5 pi over 6 would be square root of 3 over 3. Again, watch the video again if you're not sure what's going on, or you can send me questions on Remind. All right, let's look at the properties of the tangent functions. Just like properties of sine and properties of cosine, we have properties of tangent. So suppose our generic form is A tangent B theta. A can't be 0, B is going to be positive, and theta is in radians. So pi over b is the period of the function. One cycle occurs in the interval from, okay, we got a difference happening here. It's going to be from negative pi over 2b to positive pi over 2b. That's just something you have to remember. We also are going to have vertical asymptotes when we're dealing with the tangent function. And there's going to be one at each end of the cycle. Again, when we work an example, it's going to make more sense. So you can use the asymptotes. So we've got 2 of those. And then 3 points within. Again, we're breaking it down into the 5 points. So we're going to have those equal pieces. So to sketch one cycle of the tangent circle, we have, the tangent curve, we have 2 asymptotes and 3 points. So as with sine and cosine, the 5 elements are equally spaced through one cycle. The important thing to remember is the pattern. Asymptote, -a, 0, a, asymptote. Okay, and here's our a. So let's look and see what this is going to look like. All right. if A is 1 and B is 1, this is what the tangent would look like. You're going to end up with an asymptote at negative pi over 2. You're going to end up with an asymptote at pi over 2. Then you're going to plot your 3 equally spaced points, and that's going to be what the tangent looks like. Of course, this is a tangent where A is positive, okay? So it is increasing. If A is negative, then it's going to be decreasing. All right? Okay, let's try graphing a tangent function. All right, we're going to sketch 2 cycles of this graph. And the equation is y equals tangent pi theta. So the period, like I said in the properties, is pi over b, which is equal to pi over pi, which is 1. So we're going to figure out where our asymptotes are going to be located. So negative pi over 2b and pi over 2b is going to give me negative 1/2 and positive 1/2. So one cycle is going to occur from negative 1/2 to positive 1/2. So that's a distance of 1, right? So if we split that 1 in half, we would get the point that lies in the middle of that, which would be 0. Then if we split the distance from 1/2 to 0 in half, we get negative 1/4. Then if we split the distance from 0 to 1/2 in half, we get positive 1/4. So our asymptotes are going to be at negative 1/2 and 1/2 because we calculated that. But they want 2 cycles. So you have to either look to the right or look to the left. We're going to move right to find the next asymptote. So since the distance from asymptote to asymptote is 1, if I add 1 to 1/2, I'm going to get 3/2. So that's where I get the other asymptote in order to do 2 cycles that they're asking for in the problem. Okay, so dividing the periods into fourths and locate 3 points between the asymptotes. So we went over that and everybody should be good there. All right, so now I've just written out how to divide the distances to get those other 3 points. And now we're going to use the pattern. Okay, so remember in this case, A was 1. So negative A would be negative 1/2. Positive A would be 1. Okay, the first points we calculated here. So this is where we get the negative 1/2, negative 1/4, 0, 1/4, 1/2. So my ordered pairs would be negative 1/4, negative 1, negative 1/2, 0, 0, 0, 1/4, 1, 1/2, 0. So I'm going to put the asymptotes in at negative 1/2 and at 1/2. Okay, so just that's going to be where the asymptotes are located. So you can think about it as an ordered pair. I put it in with 0, but really it's just the location on the x-axis that your asymptote is going to be drawn. So asymptote here, asymptote there. All right, now let's plot our point. Negative 1/4, 1 is right here. 0, 0 is here, and 1/4, 1 is here. Okay, then you've got that kind of graph that I'm always horrible at drawing that's going to go like this. All right, so that's our first one. It's increasing because A is positive 1. Now we're just going to shift it over, and within this cycle, we're going to put the points the same way we put the points here, and we will draw our second one. Of course, mine just looks like a line that had a rough life, but it should look like your tangent line. And it's increasing when A is positive. It would be decreasing if A were negative. Okay, if you have any questions about tangent, just send me a message on Remind. Watch the video a couple times. Start memorizing that unit circle. It will make your life easier. And I'll see you tomorrow.